Hi guys, welcome to your third tutorial on matrices. Yes, this is the reread version, and let's start off right away with the third operation on matrices, which is multiplication. Right. So guys, multiplication has two portions to it. First one is scalar multiplication. This is the very easy part. I'm just going to write multi actually. Multi. So guys, if I have a matrix A, which the exam or the test or the book denotes as 3 times 1, 2, 9, 6. This is guys, this is 9. Okay, I'm sorry. A equals guys then as 3, 6, 27, 80. My math ability is not wrong. Okay, so guys, if you have something like A equals 3 times 3 outside the brackets and something inside the brackets, that's matrix. So guys, you multiply 3 with each element and you get 3, 6, 27, 18. Right guys, it's as simple as that. This is known as scalar multiplication. Let me now move on to the second segment of multiplication. This is just a tougher bit, so please just pay attention here. This part involves attention, like great attention, because it's a bit tricky. Yeah, so I'm sorry. Alright, if you have a matrix A, right? Let's A and it equals something like A equals 3, 5, minus 1, B equals 4, 7. Matrix A order 2 by 2. Matrix B order 2 by 1. Alright, so I've got this matrix and this matrix B, and guys, matrix B, if you already noticed, is a column matrix because it is only one column, and here there is only one column. Now guys, the question demands A times B. There are certain rules you have to cram up while you're performing multiplication. Guys, if A, this already I've already taught you this, that this is the number of rows and this is the number of columns. Similarly here also, this depicts the number of rows of matrix B, this depicts the number of columns of matrix B. So guys, A times B, when you're performing A times B, your number of columns of the first matrix. Now guys, if it says A times B, first matrix is A, second matrix is B. Okay, if it says B times A, first matrix B, second matrix is A. So guys, if you have to perform A times B, the number of columns of the first matrix is always equal number of rows of the second matrix. Now this is something you have to cram up. This is the rule. If you're intelligent, you'll figure it out on your own later when you've actually performed the multiplication as to why is this case. Alright, so guys, that's the first rule. So now let A be another variable name which depicts my A into B. Alright, so now I'll be performing the various operations you need to understand. Guys, whenever you're multiplying, please take this down as a rule. So guys, you always multiply this way: right direction, down direction. Right direction means traversal of the row left to right, down direction means traversal of the column from up to down. Okay, right direction, down direction, right direction, down direction. Okay, there are two directions and not one direction. Okay, if you know what I mean, you'll understand when I'm actually performing it. I will give you another example after this. Okay, alright. So now this would imply that I multiply this particular 3, this is the first element, with 4. 3 times 4. Please take it as a rule, you're always performing a plus. Okay, it's always a plus here. Okay, so it's a plus. Okay, I just realized one thing, that I will be needing a little more space here, so I think I should just drop this out. Okay, let's just finish this up. 3.4 meaning 3 into 4. Okay, 3 into 4 plus 5 into 7. All right. Now again, you'll be stuck to this one row, this column. Perform this row into this column, and it's 3 times 4 plus, it's always a plus, guys. 5 times 7, not 3 times 5, 4 times 7, or 3 times 7, not 5 times 4. No. Next, what you do is go on to the next row. Please, left to right, not right to left, and up to down, 4 to 7. Now what you'll have is, I'm closing this with a different color, minus 1 times 4 plus 2 times 7. Now this, guys, I'm not going to hold this out because I know this is really easy, but I don't feel like. Guys, this comes out to be 4710. I've done this before. 4710, yes, that's your answer. Now in case you still don't understand what I've done, traversal left to right from this row. So just take this row first time, just take this row and this column. Since there's only one column here, I will be doing another column, another matrix which has 2 columns. So you do 3 into 4 plus 5 into 7. That's your rule. Only one column, fine, you're done with this row. Now take the second row, minus 1 times 4 plus 7 times 2. Compute this. This would be 12 plus 35, 47. This is minus 4 plus 10 plus 14, which is 14 minus 4, which is 10, right? So this is how we do matrix multiplication. That's pretty much it. Please remember that number of columns of the first matrix must always equal number of rows of the second matrix. Guys, answer is of a matrix whose order is 2 into 1. Another rule to remember this, or figure it out, or just recheck your answer, is that if you've taken this column, I mean this number 2 and this number 2 here, because column first and row of second, the numbers that are left, 2 and 1, just write the first number, first matrix ka number 2, multiply, just write across and write the second number 1. 2 into 1, what have you got? This is the same as the order of this matrix. Okay, guys, so this is another way to check your answer, that your answer must always be 2 by 1 matrix, and which it is. So my answer is correct. Alright, guys, so now let's move on to another example where there are 2 columns. Okay, let it again be B, and I'm just going to use Anil Agarwal's book for reference. Okay, so the second example, he says A equals 1, 5, 2, 0. You can come up with numerous examples if you want to practice. Just make the requisite demands meet and perform multiplications at in your copy. B equals 3 minus 1, 4, 6. Guys, matrix multiplication is 2 times 2. Here also, I'm really sorry, order is 2 times 2. Here also order is 2 times 2. So if you actually see, then both A times B and B times A are possible here. Both of them are valid. However, I'm going to tell you this beforehand, the answers are not similar. Okay, I'm not going to find out the B times A the working of B times A. I will tell you the answer, and it is not coming out to be same answer as A times C. So I told you A times A is not necessarily equal to B times A. It might just turn out to be sometime where you have identity matrices or null matrices, something like that. However, just don't get confused right now. Just say that they're not necessarily equal to each other. Okay, guys, now let's perform A times B. As I already told you, we will follow the same rule. So I'll write, colors. Okay, A, B equals, alright, right, left, right, up to down. Okay, left, right, up, down, left, right, up, down, left, right, up, down, this direction, this direction. Now go row by row, and each row with each column, and then go down to the, once you finish with one row. Okay, so I'd say 1 times 3 plus 5 times 4. Okay, it's always a plus, remember. Okay, and now will come also the resulting matrix will have an order 2 by 2. Okay, just remember that, because the if I take up the column of the first one, the row of the second one, I'm left with 2 and 2. That's what my answer order is going to be. So this and another element here, another element here, another element here. So all these three places are going to be filled with elements. Now let's see what they're going to be. So now you go, you take the same row and again with the next column. So 1 times minus 1 plus 5 times 6. Next 2 times 3, this is a times, okay, 2 times 3 plus 0 times 4. You should be knowing that 0 times 4 is 0. I mean, of course you know. 2 times minus 1 plus 0. So 0 times 6, but it's actually 0 only. Plus 1. Okay, so this will turn out to be okay, fine. So now our answer is going to look like 23, 29, 6 and minus 2. Guys, this is what your answer is. This is the correct way to do this. If at all you have a minus here, like there is none over here, none of the examples have this, but if you have a minus sign here, then please put this in a bracket. So suppose you have like something like minus 5 times 4. Okay, don't get confused with this minus and this plus. Just put a bracket there. Compute minus 5 times 4, it's minus 20. You already know. So 3 times, so 3 times 1 is 3, so 3 plus minus 20 is nothing but 3 minus 20, which is minus 17. But here this case there is no minus, so our answer is right. There is only a plus sign, so there is no need of putting any brackets. Your answer is 23. That's the first element, and so on and so forth. So guys, that's pretty much it. That's AK signing off.